Alright, we are in part 3 finally. We're looking at examples 7 and 8. The other two videos are converting right now. Hopefully we'll get all these up tonight for you guys. Okay, a ball is dropped from the top of the Washington Monument at 500 feet high. It doesn't sound like a lot of information, but there's a lot of things going on here. First, the initial position, in other words, the initial height, is equal to 555. And a ball is dropped. If it's dropped, it's not pushed, it's just dropped. So that means that initially the velocity was just 0. So we should create an equation before we get into these questions here, but let's think about what S of t would be. S of t, if we're talking about feet, is equal to negative 16 t squared plus v sub o times t plus s of o, which in this case that means S of t. Oh, looks like the computer's slowing down a little bit here. S of t is going to be equal to negative 16 t squared plus our initial velocity is 0, so that second term there is out, plus 555. So how long will it take for the ball to hit the ground? In other words, when does it hit the ground? When does S of t equal 0? Well, that means that this function right here would equal 0, negative 16 t squared plus 555. Well, if we move 16 t squared over to the other side, then we can solve the algebra for this. Remember, it's saying how long. In other words, t equals something. Time equals something. So I'm going to divide both sides by 16 to solve for time. T squared equals this fraction. And then the real question is, what's the square root of that fraction? Because that's what equals t. So let's calculate that with the trusty old calculator here. We're going to be doing the second square root here of 555 divided by 16, and we get 5.8896. So t equals 5.8896, and as we were talking about in class, kind of humorous, but still very sad. You jump out of the Washington Monument, you have this long to live. Well, not even jump, you just kind of step. You're not pushing, you're just dropping. Find the ball's speed at impact. So you drop a ball, it falls for 5.8896 seconds. T equals 5.8896 seconds. Then what's v of t equal? Well, that's going to be negative 16 times that squared plus 555. So I'm going to do negative 16 times my answer squared. So I'm going to do second answer, which is the negative sign, squared. Tricky, tricky. Using the work so I don't have to redo it. It's called recycling. Save the planet. Wait a second. That's my position. Velocity does not equal that. How do we calculate velocity? Well, we need to take the derivative of position. It must be getting late, making silly mistakes. So velocity is the derivative. That's going to be negative 32 times t plus, that's it, negative 32 times t. So I'm just going to approximate this then. Negative 32 times 5 point, what was it? 8896. 8896. And that's about negative 188. So the velocity is approximately negative 188. But the speed is the absolute value of that, which is 188. Are we meters or feet? Feet per second. Done. That was a fast one. Let's wrap up this last one pretty quick here as well. Okay, so we bought a ticket, and it's a special roller coaster at an amusement park. It moves in a straight line. That's boring. It just moves. It's almost like the Superman, except it doesn't even go up. It just goes straight. So the position is this kind of complex function here. And we're looking at an interval between 0 and 120. So that's helpful. They're actually giving us the interval there. And then we need to find velocity and acceleration functions. Well, velocity is going to be the first derivative. That's s prime of t. And that is equal to, we drop down the 3, we get negative 0.03 t squared, plus, we drop down the 2, this is going to become 2.4 t. Then if we want to find acceleration, which is s double prime of t, that's equal to our acceleration. That's the second derivative. So now we're going to have negative 0.06 t plus 2.4. Okay, first question, part B, when? When means t equals something. When is the roller coaster stopped? In other words, t equals what when the velocity equals 0. So let's take our velocity, set it equal to 0, and solve for t. So we're going to have negative 0.03 t squared plus 2.4 t equals 0. Well, there's two times when this happens. Right at the beginning, when t equals 0. But if we factor this, we could find the other one as well. So I'm going to factor out a 0.03. So if I factor out a 0.03 t, I should have, this would be a negative t plus, I think this is going to be 80. Is that what it is? Yeah. Equals 0. So, you know, t equals 0, of course, from this first piece. But from the second piece, t equals 80 seconds. Okay, so that's when it stopped. Money. We're done for velocity equals 0. When is Paul speeding up and slowing down? Oh, okay, so speeding up, that means that a of t is greater than 0. Or a of t is opposite, not opposite. A of t is equal, I can't even think about this in the right direction. Okay, a of t and v of t, or velocity and our acceleration, are the same as far as positive or negative. Slowing down means that we're opposing. So I'm going to draw a graph here, actually two graphs, of these two functions, and let's see what happens. Function we have. Move this over so we can see a little bit better. We'll clear these old functions. The first one is negative 0.03 t squared x squared, not 2, squared, plus 2.4 t. And then the second function is going to be negative 0.06 times x, and then plus 2.4. That's just a linear function. Okay, so now when I graph this, my window, I'm not going from 0 to 20, I'm going from 0 to 120 for my interval horizontally. And let's see what our graph looks like. Okay, so I got a lot of stuff happening there. It looks like I need to look at some of the negatives too. So first thing I should change, my y maximum, let's just go up to 100. My y minimum, let's go to negative 100. Let's see what we have now. So we got one of those going up, then the other one, ooh, that other one's really close to 0. Really close to 0. So we need to zoom in even better. So we're talking like negative 50 to 50. Negative 50 down to 50. And our y scale, we could probably go by tens. And our x scale, we don't need to go by ones, so we should go by tens for that as well. Is that good enough? Let's take a look at it. So there's one of them, and there's the other one. Okay, so something's happening right here. It looks like it changes from positive to negative right there. So what's happening? When does that change? That's interesting to me. So let's find that out. So I want to do a comparison of V of t and A of t. When does V of t equal 0? Well, we kind of figured that out. At 80 seconds, it equals 0. And before it, it's negative. And then, or no, it's positive actually. And then after it, it's negative. A of t also has a split. A of t equals 0. When does that equal 0? Well, if I were to solve this, A of t equals 0. We're looking at negative 0.06 t plus 2.4 equals 0. So that's negative or positive 0.06 t equals 2.4. We divide both pieces by 0.06, 0.06. 6 is going to go in 24 4 times, but in reality we're looking at 40 because of the difference in the decimals. So here t equals 40. So at A of t at 40, it's here, and it's positive before that, but it's negative after that. So there's this time in between, right here, between 40 and 80, when we're positive and negative mixed. What happens when those two things are mixed? When our velocity is positive, our acceleration is negative. That means that we are slowing down. So from 0 to 40 and from 80 to 120, we have the same. So we're speeding up, speed up. But then between 40 and 80, over that interval from 40 to 80, we are opposites. So we're slowing down. It's kind of an advanced thing there, but by the end here, hopefully you guys are keeping up with that. Looking at velocity and acceleration, when they're positive, when they're negative, when they're the same, when they're opposite. Where is Paul at critical times in his ride? So we're talking about when V of t equals 0 and when A of t equals 0. Well, we just kind of figured this out. We said that V of t equals 0, pardon me, when t equals 80, and here when t equals 40. So what I'm really trying to figure out is what's S of 80 and what's S of 40. Well, just for time's sake, because we're not really pushing the idea of getting exact answers. But we know that we're going to be looking at feet. Is this given in feet? T is given in seconds, so it's car in feet. But let's look at the measurements here that we're going to plug in. S of 80 means that's going to be negative 0.01 times 80 cubed plus 1.2 times 80 squared. And similarly for 40, it's just going to be negative 0.01 times 80 cubed plus 1.2 times 80 squared feet. So we're going to leave it there. Why? Because you can calculate that. That's minor stuff. But the general idea, speeding up, slowing down. Speeding up means same. Slowing down means against each other. Critical times were these two pieces here. How do we know that something stopped? That was velocity equals 0. How do we find position or velocity and acceleration? Its derivatives. Pretty straightforward stuff. Alright, so that's it. Videos are done. They're uploading now.